Okay, so I'm supposed to remember, I'm supposed to do 13.1, number 48. And for that, I'm supposed to remember that there's a Fibonacci sequence that starts with 1, 1, and then you get the next term by add the previous two. So 1, 1 gives you 2, 1 and 2 gives you 3, 2 and 3 gives you 5, and I'm supposed to write out the next 4 here. So what are the next 4?
8,
8,
13,
13,
21.
21, and 34. Right, this is the next 4. No worries. Okay, so then I'm supposed to write an expression for an in terms of an minus 1 and an minus 2. Okay. So how do you get the next term from the previous two? Perfect. You just add them together, right? An minus 2 plus an minus 1. You guys all see that? I think I wrote this out the other day, right? As an plus 2 is an plus 1 plus an. You guys see that? What's the difference?
the signs.
Just where you happen to think that you're sitting, right? So you think n's the term you're starting at, and then you add the next term to get the one that's 2 ahead? Or do you start at the one you want and add the previous 2? I don't really care. They're the same thing. You guys cool with that? Okay, so that gets me B. Then C says, suppose Rn is the ratio an over an minus 1. Okay. And then they say, and Rn is the ratio, Rn minus 1 then should be the ratio between what?
An over an minus 2. Oh, just kidding. Never mind.
Close. A something over an minus 2.
And 1.
An minus 1 over an minus 2, right? Okay, so they tell me that, and then they say, using my answer to part B, find a formula for Rn in terms of Rn minus 1 without any of the A's. So I want this. Rn minus 1 is Rn is a function of Rn minus 1 without any of the A's. Weird, right? I kind of don't maybe know precisely where to start. You guys see that? Okay, so I'm going to start by just thinking. What do I need to start with? If I want to start with this formula I have in part B, right? So I want to start with this thing. How am I going to get an Rn in there?
You're going to substitute something?
Yeah, I could try to substitute something. I think I've got an an, right?
And you got an an minus 1.
Yeah, and there's an an minus 1 over there.
Oh, but you're worried about signs. The signs aren't the same.
Yeah, the signs aren't. Damn it. So I need an an over an an minus 1, right?
Yeah.
Okay, so let me just take this thing and multiply by 1 over an minus 1.
Okay.
Why would I do that?
To get what you want.
Yeah, so I'm going to get an
So you're
Rn, right?
Yeah.
Yeah.
Maybe I should write this down very carefully. So I'm going to get an an over an minus 1, right?
Yeah.
And that's going to equal
And minus 2.
an minus 2 over
And minus 1.
an minus 1.
Plus 1.
Oh, if you want to keep it, it'd be an minus 1 over an minus 1.
Huh? Oh, yeah.
If you're going to keep, because you're showing things explicit.
Okay, so if I want to be totally explicit, I'd write this, right? And then all I've noticed is this piece here is 1. This piece here is,
Rn,
that's an Rn. What's this guy?
some weird stuff.
That's Rn minus 1 flipped.
Inverse of.
Yeah, it's Rn minus 1 but flipped over, right?
Could that be 1 over Rn minus 1?
Perfect. That's 1 over Rn minus 1. So I'm going to rewrite this as Rn is 1 over Rn minus 1 plus 1. Cool. That actually explains why this goes to the golden ratio. Right? 'Cause remember that the golden ratio thing was x is 1 plus 1 over x? Yeah. Ish. So I think that's going to help. All right, so let's see. And then D, the terms Rn form another sequence. Suppose Rn leads to a fixed value, R as n tends to infinity without bound, blah, blah, blah. Use your answer to part C. Oh, notice that this thing is the golden ratio. Okay, so really that's just suppose this. That's suppose that the limit n tending to infinity of Rn is some number, and I'm not going to call it R, I'm going to call it P. Cool. Then I'm supposed to come up with an equation for this thing. So I'm just going to take this guy, right, and I'm going to apply the limit n tending to infinity to both sides. You guys see that? So I'm going to get the limit n tending to infinity of Rn is the limit n tending to infinity of 1 over Rn minus 1 plus 1. Cool. And then I'm going to notice the left-hand side of that should be phi, right? You guys all see that? How about the right-hand side? Oh, which things don't give a shit about the n?
Plus 1.
Like, which things don't matter what n goes to? The plus 1 and the 1 on the top, right? Those are just going to jump. And then what happens is you send n to infinity to Rn minus 1.
Infinity minus 1.
You get infinity minus 1, which is, which is huge anyway, right? So you get R sub huge. But remember, the R sub huges turn into that phi, right? So I could really just slap a phi down there too. So there's my equation for the golden ratio.
Is that really the golden ratio? Isn't that the one you wrote down? Oh, you didn't use x's.
Yeah, I used x's last time. It's the same thing.
Yeah.
I may have written down the reciprocal.
It does.
So
It's
that,
like repeating.
yeah, so if you go fiddle with this thing, there are two roots. I may have written down the reciprocal. So I may have written down 1 over phi instead of phi, but the decimal expansions are the same. They're just off by plus or minus 1.
Okay, now, but is that equation like actually correct? Phi equals 1 over phi plus 1?
Yes.
Would that mean phi squared is 2?
No. So
Oh, I
if
get it.
you multiply both sides by phi, right, to get the phi into the top,
Oh, I get it.
you got phi squared is 1 plus phi, right, which gets you phi squared minus phi minus 1 is 0. And then you apply the quadratic formula. And I'm pretty sure now that yesterday I wrote down the reciprocal. There's two roots to this. I wrote down one of them. I think I maybe got the other one. You guys all cool?